Kia ora. Raman has sent me this problem to look at, so I'm going to do a worked example here. So the question asked to calculate the enthalpy of combustion of methanol, liquid methanol, and it gives you the equation of the combustion of ethanol, and so that's ethanol plus oxygen gives carbon dioxide and water. That's the equation at the top, and it gives you this data here. So the enthalpy of combustion of carbon, the enthalpy of combustion of hydrogen, and the enthalpy of formation of methanol. So the first step is to write the equations for each of those. So the first one is combustion, so it's carbon plus oxygen is going to give carbon dioxide. Second one is also combustion, so that's hydrogen plus oxygen, it's going to give water. And see, it's one mole of the thing that you're burning or combusting. And then the formation is a formation of methanol made up from its elements by definition. So you write those equations first, and then you've got equations. So we want to use these equations to make the top equation. And to do that, we can either multiply it by a common factor, or we can reverse them. So the first thing to see is that we've got at the top equation here, we've got carbon dioxide and we've got water on this side. So in our equations here, we've got carbon dioxide and water here. So we've got 1 mole of carbon dioxide and 2 moles of water. So we can do those equations. I'll pause it while I do that. So to continue on, I've written the equation. So we've got carbon plus oxygen makes carbon dioxide, and that's just the same as our top equation here. So we've just got the value of 394. That's because there's only 1 mole of carbon dioxide here. But there's 2 moles of water. So we want to multiply this by 2 to get water over here, to multiply this whole thing by 2. So multiplied everything in the equation by 2, and we've got 286 times 2. And then we've got methanol on this side, but in our formation equation, methanol's on the other side. So we're going to reverse this equation. So we're going to put this as the reactant and these as the products. So we'll do that. And the value for that is minus 240 kilojoules per mole. Okay, so the value for that is minus 240. So we've reversed it. So we actually have to remember to make it plus 240. Plus 240. Okay, because we've reversed it. And then we're going to draw a line underneath. There, and we're going to cancel out anything that's on both sides of the equation. So on this side we've got 2 moles of oxygen, and on this side we've got half a mole. So we're going to have 2 minus a half is going to be 3 halves of oxygen gas. We can cross that one out. And then we've got carbon, and we don't on both sides, so we can cross the carbon out. And so, and then we've got 2 moles of hydrogen gas and 2 moles of hydrogen gas, so we can cross those off, cancel each other out. And then we've got methanol, on this side, and on this side we've got the products. We've got carbon dioxide gas and 2 moles of water. And we can just check that we don't have anything else there. And that's just a way of checking that we've done this correctly. And then the value will be minus 394 plus 2 times minus 286 plus 240. And I don't have my calculator handy, but whatever the answer is, pop that into calculator, and the answer is kilojoules per mole. This is from this value here. Okay, so hopefully that helps. Let me know if you've still got any questions.